Hello students, how are you? So in the previous episode we already started some of the synopsis related to solution chapter. So the remaining synopsis we have to complete in this episode. The last topic we are closed with Raoult's law, and we have to discuss one of the formula in Raoult's law also. What is the formula I wrote on the Raoult's law? P total is equal to PA naught XA plus PB naught XB. This is the formula discussed. Already we know we have to convert this XA terms into XB terms. I write XB is equal to 1 minus XA. Suppose I want to substitute this XB value in XA. I will get the expression like this: PA naught minus 1 minus, or you can write it XA is equal to 1 minus XB. I will write this one: 1 minus XB plus PB naught into XB. So P total is equal to PA naught minus PA naught into XB plus PB naught XB. Now we get this one: P total is equal to PA naught plus, I want to take here XB is common in these two terms. I will get what expression here: PB naught minus what? PA naught. So sometimes we have to convert this XA or XB to terms. We have to use the formula like this one. So this is the formula related to which one? Raoult's law. And one more formula also we have, Raoult's law. If they are asking the pressure, okay, partial pressures or mole fractions in the vapor phase, we can use the formula like this here: P1 is equal to Y1 into P total. And same manner we write here: P2 is equal to Y2 into P total. What is Y1 and Y2? Y1 and Y2 are the mole fractions in vapor phase. Here Y1, Y2 are mole fractions. Mole fractions in what phase, man? Vapor phase. Okay. So this is related to which one means Raoult's law. Clear? So after Raoult's law, we have types of the solutions we have. That is ideal solution and non-ideal solution. So, okay, ideal solution, and one more we have non-ideal solution. Already we discussed some of the differences in the solution chapter. One, just you can recall this ideal solution and non-ideal solution. So what is meant by ideal solution means the solution which obeys Raoult's law at under range of the concentration. If it obeys Raoult's law, that is said to be what? Ideal solution. Simply you are writing here obeys Raoult's law. The solution which obeys Raoult's law is called as ideal solution. Here, what you can say here, it does not obey Raoult's law. It does not obey Raoult's law. Is called a what? Non-ideal solution. So here mainly we have to consider the interactions, or you can say attractions only. That interactions or attractions we can observe between the solute and solvent molecules only. Let us say A we are taking, and A we can imagine is a solute, and B and B are acting as a solvent. We are mixing these two, we will get a solution that we are calling as what? AB type of solution. Okay, I will write one point here: AB attractions. AB attractions are almost same as AA and BB attractions. AA and BB attractions. So it means interactions of solutes solute, solvent, solvent, and solutions are same. That solution we are calling is what? Ideal solution. Here we are writing AB attractions. AB attractions are not same. Are not same. AA and BB attractions. A and what? BB attractions. Here we are writing here delta H mixing is equal to 0. Here we are writing here delta H mixing not equal to 0. Delta H means enthalpy of the change. Enthalpy of the change is equal to 0 for what solution? Ideal solution. So enthalpy change is not equal to 0. What in the sense? It may be greater than 0 or it may be what? Less than 0. So we are mixing two solutions. Delta V mixing is equal to 0 and here delta V mixing not equal to 0. Means if they are adding two solute and solvent, there is no change in the volume. Volume change is equal to 0. Here maybe increase the volume or maybe decrease the volume. Clear? And one more here we can discuss already so many examples for this ideal solution. If you want to mix N-hexane and heptane, chlorovenzene or bromobenzene, ethyl chloride or ethyl bromide, all these comes under what type of solutions? Means ideal solutions. Okay. Non-ideal solutions you are taking acetone plus chloroform, acetone plus carbon disulfide, phenol plus aniline, ethyl alcohol and water, and one more you can take acetone and ethyl alcohol. All these comes under example which means non-ideal solutions. Mainly we can identify the differences. Sometimes we maybe get the questions if the two solutions are mixed, the enthalpy mixing is equal to 0. What type of solution it is? So we can easily identify if the enthalpy mixing is 0 or volume mixing is 0. That is said to be what? Ideal solution. So non-ideal solution means not equal to 0. Not equal to 0 already I told you that may be less than 0 or what? Greater than 0. So that we can discuss in the next topic. So here non-ideal solutions shows two type of deviations from Raoult's law. Okay, what are the two types of deviations means? One is a positive deviation from Raoult's law and one is a negative deviation from Raoult's law. One is positive deviation and one is what? Negative deviation is Raoult's law. Why they will show deviations means because there is a change in the attractive forces or interactions or van der Waals forces. So, okay, if you see the positive deviation, and here I have one point here, AB attractions are greater than AA and BB attractions. So, let us imagine AA is a solute and BB is a solvent. After mixing these two, we are getting AB type of solution. If the solution attractions are bigger than AA and BB attraction, then what happened here? The solute or solvent means A or B escape easily. When A or B escape easily, then what happened? Vapor pressure is increased. So when the vapor pressure increases, they will show what type of deviation? Positive deviation from the Raoult's law. So here simply I am writing here vapor pressure is what? Increases. So come to the negative deviation we have. AB attractions are stronger than AA and BB attractions. So okay, I already told you AA is a solute, BB is a solvent. If you are mixing these two, we are getting the AB type of solution. The solution attractions are greater than what happened here? AA and BB attraction. Then what happened here? The escaping tendency of solute or solvent is what? Decreases. If they decrease, then what happens? Vapor pressure decreases. Vapor pressure decreases, then it will come under what type of deviation? Means this comes under what? Negative deviation from the Raoult's law. Let us see the next point I wrote here. Delta V mixing greater than 0 means volume mixing is greater than 0. If the solute and solvent we are mixing, the formed solution volume is greater than solute and what? Solvent. Means what here? volume is greater than is what? Volume of the solution is what? Increases. So if you are mixing 10 ml of A and 10 ml of B, we are getting a resultant solution some 21 ml. Then what happened here? It is greater than total volume. Total volume is 20. We are getting the volume is 21. Then what happened here? Volume of the solution is what? Increases. It is concerned what type of deviation? Positive deviation from Raoult's law. We maybe get one question like this. If the two solutions are mixing, the resultant volume is greater than the given solute and solvent volume. What type of deviation? Okay, it is concerned what? Positive deviation from the Raoult's law. If you see here, delta we mixing less than 0. Less than 0 means what here? Volume of the solution is what? Decreases. Volume of the solution is decreases. After mixing this solute and solvent, if the volume is decreases, it comes under what type of deviation? Negative deviation. Suppose 10 ml of A and 10 ml of B we are mixing. The resultant solution volume is of 19 ml. So what type of deviation we are observing? This comes under what? Negative deviation from the Raoult's law. Come to the next one, we have enthalpy mixing. Delta X mixing greater than 0. Greater than 0 means what here? It is a endothermic process. It is absorbable. If the two solutions are mixing, it is greater than delta X mixing is greater than 0. Okay, that is comes under what type of deviation? Positive deviation. Here you can see delta X mixing less than 0. Delta X mixing is less than 0 means what? Delta X is negative. Delta X negative means comes under what type of it is? It is an exothermic process. Come to the next one, we have P total greater than PA0 XA plus PB0 XB. Means resultant solution total pressure is greater than individual pressures of each solute and solvent. It is always what? Greater than, that is comes under positive deviation. It is negative comes under what? Less than is comes under negative deviation. Let us see one more point here. They will form minimum boiling isotopes only. That positive deviation from minimum boiling isotope. Negative deviation forms maximum boiling isotopes. We will discuss one of the isotopes next. Clear? And let us see the example we have. Ethyl alcohol and acetone, water and methyl alcohol, carbon tetrachloride and chlorine. All these comes under what type of deviation? Positive deviation from the Raoult's law. Examples are very, very important. Sometimes they give 4 options with the different examples. They are asking which of the following have positive deviation or negative deviation asking. We can easily identify, or we are getting one question from this positive or negative deviation examples. So come to these examples on negative deviation. Chloroform acetone, phenol and aniline, chloroform and diethyl ethanol. So this comes under what type of deviation? Negative deviation from the Raoult's law. So examples are very important for us. In the solution chapter already we discussed elaborately how they will form a positive deviation and how they will form negative deviation. Simply we will discuss here one example with the positive and what negative deviation. Let us see ethyl alcohol and acetone. Ethyl alcohol, what is the formula of ethyl alcohol? C2H5OH. Let us see here ethyl alcohol. Ethyl alcohol generally they will form a hydrogen bonding only. It is a intermolecular hydrogen bonding is formed. Generally the hydrogen bond is formed between hydrogen of one alcohol and oxygen of the other alcohol molecule. Here what we are observing here we are observing mainly the formation of hydrogen bonding if it takes place when hydrogen bonding is formed. Means what here there is a strong attractive forces can be developed between oxygen and hydrogen of the ethyl alcohol molecule. So what's the intermolecular hydrogen bonding is formed. Okay, then what we are adding here, we want to add acetone from the outside. here I want to write, I want to add acetone. What is the formula of acetone? CH3CO CH3. Here CH3CO CH3 and CH3CO CH3. Here the attractive force are strong only. Whenever adding the acetone molecule, it will disturb the hydrogen bonding between two alcohol molecule. Then what happened here? Attractive forces are become what? Weaker. If the attractive forces are become weaker, it will show what type of deviation? It will show positive deviation from the Raoult's law. Like this, we can explain the remaining examples in positive deviation. If the attractive forces are weaker due to addition of acetone molecule, then what happened here? The vapor pressure of the solution is what? Increases. Thereby, it will show a positive deviation from the Raoult's law. Let us see the one more example from negative deviation. I want to take the example here. Chloroform plus acetone. What is the formula of acetone? CH3CO CH3. Let us see how it will show a negative deviation from the Raoult's law. Let us see the chloroform. We have chloroform and acetone molecule right here, CO and CH3 and CH3, and here we have carbon, hydrogen, chlorine and chlorine. I want to write the two molecular structures like this. Then what will happen here? There is a chance to form hydrogen bonding between oxygen of the acetone and hydrogen of the chloroform. Once the hydrogen bonding is formed between which one? The hydrogen bonding is formed between oxygen of the acetone molecule and hydrogen of the chloroform molecule. Then what happens? The attractive forces become what? Strong. If the attractive forces are become strong, then what type of deviation it will show? Negative deviation will show, because there is a decrease in the vapor pressure of the solution. So this is the example of which one? A negative deviation from the Raoult's law.